So yeah, welcome all. Uh, just to give you guys an update on how we are progressing on the shared mempool stuff testing. We ran into a few issues writing the Hive simulator for our implementation because there was no ARM images available, or I mean, we couldn't build our Docker image on ARM because we were using an issue. We found an issue with the node binding for the RocksDB, which we use in our implementation. We managed to find a fix for that, and now we've just published that. I have also submitted a PR for the updated debug RPC interface that's required to perform the simulations for the P2P testing. Hopefully, Shahaf will be able to approve that after his review today. And I believe Vid and Will tested out their implementation with our boot node, but they ran into some issues. I'd be happy to hear where they are in terms of testing. And I'm continuing the work on the Hive simulators. And now that the issue with the Docker images is solved, I should be able to progress, and I'll keep you posted on how it goes. So, Vid, do you have an update of how the testing went, and was there any issue with the hosted setup that we have? Were you able to connect successfully?
Yeah, so there was no issue with your setup. We'll start testing our code, but I know there are some bugs when connecting to your node. But I cannot give any more updates because he's testing that at the moment.
Okay, cool. Sharif and Dan, do you have an update on where you guys are with the P2P testing?
Yeah, I'll give an update. We started implementation this week. So hopefully we'll have something to start testing against your node in the near future. So working through that right now. A couple things. I'll be putting up a PR soon-ish, just to go through like a few nits on the spec, like broken links and and wording of things that are unclear, and some things that might need to be specified. One thing about the spec that I ran into when building the serialization side of things, or specifically the deserialization side of things, is that we don't currently have a limit on the size of a user operation that's specified. We have there's a gossip in the request response domain. So we've got a limit on the maximum size of a gossip message, but not of a chunk in a request response pair. So I might just, would it be best for these sorts of things to just like open issues against the repo, or to put them in a PR, or what's the best way to put feedback onto the existing spec?
I mean,
I think that opening a PR is preferable. Obviously, you can also we can either have the discussion there or on Telegram, but opening a PR is completely reasonable. We're welcoming all PRs if they make sense. Yeah.
Great. Yeah, that's the only missing piece I've found so far. It's just a way to limit that max size. It might just end up being the same as the gossip size max or something like that, just so we can defend against, when you're deserializing UOs, you probably need to defend against something that's a little bit too ridiculous, and we need to set that value across the pool. My other question, I missed the last meeting. What is the exact reasoning for needing to add this new debug method, as opposed to just sending a bunch of UOs when a bundler starts? It seems to me like they do the same thing, like calling debug set mempool versus just send user operation end times.
Right. So
I would prefer not to have to maintain another API just for debug if we don't have to.
So there are two things. Firstly, once you send a bunch of user operation, it performs a simulation on those user operations as well. And just needed an easier way to seed the local mempool without having to perform, apart from the basic sanity check, serialization, so that we can quickly get around the simulation of the shared mempool rather than waiting to complete the simulation and then testing on the propagation.
So it's just a speed thing. We're
Yes.
just worried about being able to seed the mempool quickly.
Yeah.
I feel like that's not necessarily a Dror, you're muted. I don't know if that's necessarily a strong enough reason to need to add a new API endpoint.
Because simulation takes a long of time on the nodes, like tens or hundreds of milliseconds. I think that there is a point of that, but I wanted something more of a debug send use operation, which is send use operation skipping validation in debug mode. That if you explicit as a flag for send use operation, you explicit that it will work with normal send use operation, but slower. Since you need to feed more than one, then you want to be able to feed them fast. But I prefer, instead of introducing a completely new API, just flagging a debug mode for existing one for the send use operation. Like either debug send use operation or send use operation with the option don't verify. So if you ignore the don't verify, it will work, but slower. If you don't ignore this this flag, you skip validation, of course, only in debug mode, because you trust your sender that it is a valid user operation. And another nice feature of skipping the validation, it's easier to test later spamming, because I feed the bundler A with invalid user operation, and it faithfully, without any further modification, propagate it to the other bundler, and the other bundler get it as a spam because the other bundler validates it and sees that it's invalid in some aspects. So to my understanding, this is a simpler modification for debugging purposes for a bundler. A flag saying skip validation on a user operation.
But there is a probability that this could be misused in a real production environment, right? Who specifies this flag? If the person consuming the send user operations ends up setting the flag, then
it should only be available in debugging. Otherwise, it's an attack vector on the entire system. So only in debug mode, you want to be able to skip validation. I think it's essential in order to test things like spam, see if the protocol can withstand the spamming node. But another thing is, one benefit of using an array rather than sending them one by one is not just speed, but also atomicity, which may or may not be an issue depending on the bundler implementation, because sometimes you want to bring the mempool to a certain state to have a certain user operations, because you want to see if it will try to put them in a bundle together, and then which would violate certain safety properties. But if the bundler might start sending bundles before you finish sending all of the user operations, it will be really hard to perform this test. For the peer-to-peer, it doesn't matter, but if you want to use it also to test things related to bundling, then atomicity matter.
We also
we have
already have a solution
endpoint
for that. Yeah,
Yes,
exactly. Yeah. We set the bundling mode to auto manual just exactly for that.
Yeah, exactly. So if you have that, then it gives you the atomicity.
Yeah, we needed to have that for previous tests as well, even before the mempool. Otherwise, it would be held to check some things.
Right. So okay. So since we have that, then I guess an array is only a speed optimization. So I don't know how important it is, but it is important to be able to skip validation, and it will only be active in debug mode, never in production.
So just another point from my side, at least, the way that we have structured our mempool being like the amount of the data that we persist along, not persist, but that we keep in memory alongside a user operation requires validation to have run before. So we take a bunch of the data that we pull out of validation, like which contracts it's accessing, which, you know, basically all of the things that are needed to be able to tell the bundler, you know, how to do some of the validation rules, which entities are staked, that sort of thing. All of that stuff that you learn during validation, that you can't learn just by looking at a user operation itself. So for us, entry into our mempool requires validation. We could go refactor a bunch of code to make all that stuff optional, but then it would be just pretty gnarly to have to deal with that data maybe not being there.
Just a second.
You need the data, but you can still skip the. I mean, you need the. You can run the simulation to collect the data, but then accept it even if it violated some rule. It's that's
true. We could do that. We could make it. We will still run simulation, but we can say, hey, just let everything in, make it a fully accepted.
It's equivalent to having an alt mempool with an allow everything rule. It's like, you know, if you have the bundler and it simulates, but you also define an alt mempool that accepts everything, it will behave exactly this way.
The point is that, do you require this information? Like, can you fake and say that I'm accessing only the explicit entities?
We could fake it. We could have like a debug path that's like create a fake one of these.
I tend to opt to a specific debug method instead of debug parameter. That is, debug send user operation versus adding a flag to user operation, because it behaves differently. That's one. And if you can, I'm not sure what is the side effect, because if it's possible, just, yes, to fake this information, because one of the reasons of this API is to be able, for testing purposes, to load the mempool with the semi-valid stuff, because it could be completely broken, of course, and see how it behaves on second validation in order to have minimal modification to the bundler for debugging in other places. So we do allow entering invalid user operation deliberately into the mempool in this debug mode, which means faking some of the stuff. And for some of the testing, we will need to load a large number of user operations. Right now, for some of the reputation tests, they're not fully active, but they're very slow because they need to load large numbers, because the other way to test it is change the settings of a bundler to much lower numbers so that the load time will be in a reasonable time. That's why I prefer skipping validation. It makes it easier to load into the mempool. And yes, fake it instead of do real tracing. Again, you need to check if it's possible.
And also, and I think another reason to use a different method rather than a flag is that it's much easier for DevOps to later verify that in production the debug namespace is turned off. You only need to check one thing. Yep. So so this way you avoid configuration mistakes that will get you in trouble.
Okay, I think I'm on board. I'm a little bit protective against needing to add debug code, just because debug code in my mind either gets stale or it's harder to maintain, and if it's not in production, and what's the point of having it add to complexity? But it does sound like it'll make testing easier, so I'm on board.
Cool, thank you. Sheriff, you were looking to provide an update on the shared mempool.
Yeah, we still didn't finish the implementation. We still need some time.
Okay. If either of you, your team feels that there might be a delay, ideally before DevConnect, we'd like to have at least 2 teams having an implementation of the shared mempool. So just keep us informed if you foresee any delays. Yeah.
Yeah, sure. Yeah, sure.
Thank you.
Pata, I want to take. I'm I wonder whether we should talk it here or take it offline regarding the testing mode. Hive mode versus using a PyTest-based test. I suggested like bringing up a Docker image with multiple Dockers. I also sent you a message. I believe you
Yeah,
saw.
I saw that. I've been I didn't get to read that in detail, but a bit of what you said, even in Hive mode, it spins up multiple Docker images for each client in question, and then performs the same testing suit. So in theory, what you described in your message can be achieved in Hive mode as well. Yeah, we can probably take it offline as well, Dror. Let me read through what you suggested, and then we can work out what's the best way.
Okay. Because my suggestion is try to use the same framework we have for testing both instead of introducing Hive.
But eventually, the idea was for bundlers to become a kind of block builders and merge with the when you enshrine it, right? So at that time, it would probably make sense to follow the same testing principle as the existing ETH1 and the execution and consensus layer nodes. So would this be an issue then?
You might say it for all the tests that we're doing, not only for P2P testing.
No. Yeah, I understand, but I thought it was possible to switch or port the existing tests for RPCs easily into Hive as well, because you had the ability to write simulators for the regular RPC and reuse what you were testing within the Hive framework.
Okay.
I mean, we can always discuss this offline, or let's work out what's the best way.
Okay.
So yeah, that's all I had. I think we are open to discuss any other questions. And Dror and Yoav, I believe you had some thing to.
Yeah, so I had one that I wanted to mention. So recently we discussed in the group the unused gas attack that Dan mentioned, and we wrote a proposal for something that we plan to add to entry point if everyone here is on board. So Dan already commented and I replied, but I wanted to make sure that everyone saw it in case anyone sees a problem. So it's so we put a message with the pull request that Shahaf created for it. So
we can explain a bit. Do you want to explain a bit about the attack and then the proposed solution you have?
Go ahead.
Okay, so the attack is fairly simple, as Dan already described it. Is that any user can declare an arbitrarily high call gas limit in the user operation and simply not use most of it. So it can just take up space in the block gas limit for the bundler, and instead of basically just preventing the bundler to bundle more user operations in the same bundle. Okay, so that can lead to griefing the bundler by making it far less profitable, simply because there is a lot of unused gas that the user operation caused. And currently there is no mitigation at least in the contracts, and there is no proposed mitigation in the bundles. Now, the issues that we found is that adding an off-chain mitigation for it is a little bit problematic. So we can discuss it further, but basically the proposed solution is having the client pay for an unused gas that is far too high. Okay, you can see the proposal in the pull request, but basically having an on-chain mechanism in entry point to charge part of the unused gas still from the user to prevent from having such attacks. So the point of that is that to basically disincentivize clients from declaring like a call gas limit that is 10 times what they are actually going to spend basically in the user operation. Yoav, do you want to add something?
No, I think so you explained it well. There's the and since the goal is to penalize huge operations, huge user operations with a lot of unspent gas. We want to make sure that we don't penalize or we don't over penalize any normal transactions, any normal user operations. So for example, a small user operation might end up stating high gas gas limit that is too high. For example, if someone else if it's going to access some slots during execution, and then another operation warms them up before, so the gas ends up being lower. And then the penalty would eat some of these savings, which is a shame. So for a small user operation, we don't want to activate this mechanism. Therefore, we thought of only doing it for particularly large ones. Now the question is, what constitutes a large user operation? So currently in the proposal, we wrote 1 million gas. So this entire mechanism is only activated above 1 million, but I don't know if that's the right number or should we even have a number. But the purpose of having one is that if we don't set one and we only look at the percentage of unused gas, then in a very small user operation, the percentage of having 2 or 3 slots pre-warmed can be sufficient to start penalizing.
Yeah, I just to give another kind of from the field observation on this gas limit stuff. The whole conversation came up in the context of us trying to basically saturate Polygon with user operations. So we were trying to actually create bundles that could push the gas of a Polygon block like to almost the 30 million value that they have. We actually target 15 million so that base fees don't explode. But and one of the issues is when you're a bundler, you have to go off of gas limits. You can't go off of actual gas use because you're not building the block. And even with user operations that weren't egregious in their overestimation, they were just maybe 50% overestimating the call or the verification gas limit. When you build you're building a 15 million gas bundle and it only uses 7.5 gas, it cuts your throughput in half. So the throughput of Polygon, or what we were able to get, actually at the time we were only filling about 25% we were only using 25% of the gas limit of our bundles. And so with a single bundler EOA, you're only able to actually use 25% of the gas limit. Now, if you split that into 4 bundlers, you can actually then hopefully use closer to 100%, but it limits the ability for a single bundle EOA to saturate the network. So my issue with applying this only
one way bundling, as I see it, bundling is an interim solution to a gas problem, and it of course will go away when we do a native account abstraction. But it is a way to save gas, but you don't have to fill it. Like if you create a bundle and you verify and you see that this transaction takes like 25% of the block, you can submit yet another bundle within the same block. You can submit multiple bundles. Nobody prevents you. Like nobody prevents you from creating a separate transaction for each user operation.
So, yeah, no, totally agreed. I'm more so that if your bundler, you either have to split, you have to send either run multiple bundler instances, like multiple EOAs, or try to build more sequential transactions that land in the same block. It's easier if you could just submit one transaction.
Of course.
So my only issue with having this only apply to really big transactions is if the mempool is flooded with really big user operations. If the mempool is flooded with user operations that are all 50% overestimated, then each of your transactions will only have like a 50% gas usage efficiency. Yeah. So I would rather apply this as a blanket policy and make it so, ideally people aren't overestimating by more than 10%, so that we can at least get closer to 100% gas usage efficiency. It's never going to get all the way there, but I think it makes it easier for bundlers to need to track less transactions, to need to submit less transactions, and then potentially makes things like signature aggregation in the future even cheaper and amortized more, because you can build bigger bundles.
Okay, so you think we shouldn't have we shouldn't have any constant limit. It should be active for all user operations.
I think so, and I think maybe we can. The number to change would be that, like, if that 10, the threshold that we talked about, or that's in there. So if it's like the buffer might be 20% as opposed to 10%. You can overestimate by 20%, or 25%.
So first, where does the buffer come from? Is it always calculated by the wallet, or does Alchemy also add something like if I use an Alchemy node, I use the Alchemy RPC to estimate gas, do I get an accurate estimate, or do you also add a buffer on top of it?
Yeah, so there's 3 places this comes from, at least that I can think of. One is that certain wallets have had a hard time estimating validation gas, because they've had a hard time coming up with a dummy signature that should apply to all of their validation paths. So they just have a static, like, oh, we apply 100,000 gas to every validation call. So they don't even use the estimates. That's one. 2, some people do the same thing for call data. They don't even use estimates at all. They just plop a number in there. They don't even call ETH estimate gas or estimate user operation gas. And then 3 is a legitimate issue, where, and this happens a lot for DeFi users, is if they're doing something that is clearly in the call, that's clearly going to be accessing state that's modifying all the time, like if they're trying to do some trading or whatever, it's totally possible that when they estimate the gas is way lower than it actually ends up being on chain, because a bunch of pairs became tradable over over the blocks difference between estimation and simulation. So those are the buffers typically get added by those teams.
Yeah, this is the buffers for this is buffers for 43.7. I meant also when calling ETH estimate gas for normal transactions, does the Alchemy node also add something, or does ETH estimate gas give you an accurate estimate? Is the buffer added there or only by the wallet?
My understanding is that a Geth node doesn't add any buffer, and the wallet adds buffer to the gas limit.
Yeah, if it's a normal, if you're using vanilla Geth, then this is the case.
Yeah, we don't do anything different on the regular transaction side or on the 43.7 side.
So do you know what's the formula they use in wallets in order to add a buffer, like when, let's say, MetaMask?
Are you referring to application? Sorry, go on, Drew.
No, I'm saying it's both water and application. Sometimes the application adds its own, and there's no way when you get an estimate. The problem is that when you get an estimate, you have no indication of how much buffer this estimate has.
Exactly. I mean,
Yeah.
what we have experienced when, sorry, Yoav, go on.
No, go on, please.
No, I was saying what we have experienced when we've tested different bundlers with different, 4337 SDKs, the estimate that comes out of these are quite different, and we don't know why they are. It's probable that the SDKs themselves add a buffer for this. We are yet not sure if this was a value that was returned by the bundler in question, or was it a part of the SDK itself?
Mm-hmm. Yeah, so it's so different SDKs do it differently.
Yeah.
Yes, and something about the limits of overcharging or charging for the unused gas. Two things that we wanted to put initially, Yoav, we wanted to do it only on big transactions, but it's less relevant because if you have a small transaction and you end up paying over, it was small to begin with, so you didn't pay much. So if you overpaid for a 100K transaction, you paid extra.
No, I know it's. I know you're not. I know you're penalized. I mean, the absolute amount is fairly small. It's just a shame that we are losing one of the benefits of using 4337 bundling, which is the pre-warming saving. Now, this saving is a byproduct. It's a side effect. So, for example, it's not evenly distributed. The first user operation pays for the warming, and others benefit from it. But you never know whether you're going to be first or not. So it's not perfect in any case. And here you lose a little bit of it. Let's say you lose 10% of you might lose 10% of the savings at most. It's
yes. And the other thing is that you mentioned that some put fixed verification gas instead of calculating it. But since a bundler before making a transaction simulates the verification, it knows how much gas it will take exactly. Not
the problem is dummy signatures. So when you're running validation, you don't always have it's sometimes hard for users to calculate a dummy signature that gives them a valid.
When you create a bundle, it's not a dummy signature. You have a real user operation, and you validate them before you put them into a bundle. At this point, you know that this user operation will succeed because you verify the signature. It's not dummy anymore, and you know exactly how much gas it will take. So you have this gas, and you can add this 1/64 because this is the extra gas it has to have. It will not pay for it, but it will have to have it, and you do need a buffer, one buffer for the entire user operation to cover for it, so that you will have it at the end, but it is one for the entire bundle, and you know exactly how much verification each one will take. What you don't know, and you can't accurately estimate, is how much the execution will take. So
which is the biggest problem.
Yes, yeah. So I'm thinking out loud whether this overpayment we're talking about should apply only to execution and not for validation.
That's how it's proposed, actually. The overpayment is only on. But I did bring up that same point in the PR to that. So a bundler, instead of using, so if a user kind of tries to attack, not even tries to attack, or just does this, just sets a super high validation gas and it uses a lot less. The bundler, when they're setting their own gas limit, should probably only take into account the gas that was used during simulation. I guess one of the questions that I have then for Yoav, and I think you responded here, is that are there possible attacks that can be done if you do that?
Yes, I replied that there is an attack. I don't think this would be a safe way of doing it. So first of all, I don't think validation gas in itself is included in this attack vector, because bundlers already limit the validation gas, because it also, I mean, if you allow a very high validation gas, it also allows someone to attack you by sending you very big validations that actually fail. So you're already limiting. Therefore, it can't really be allowed. It can prevent you from submitting a large bundle just because they weight a lot of gas. And then, if you do want to handle it, I don't think we need to handle this one in entry point, but also the second method you suggested of deducting this gas from the entire bundle, deducting the unused part from the entire bundle, is risky because now if it does use it on chain somehow, let's say someone front run the transaction, change something, and now it consumes more gas, it will get its entire the entry point will give it all the gas it asked for, and then the entire bundle will run out of gas in someone else's in the execution of the last user operation. So you're actually causing the bundle to fail, and you will not even be able to associate it with the one that you deduct the gas from. So this is too risky. I think it can be used to attack entire bundles on chain. But the other method you suggested, the first one, does work. It's you can just say, I'm going to drop this user operation. If user operation state at a very high validation gas and actually uses very low, you can silently drop it. But I'm not sure it's really needed because of the validation gas limit that the bundle is going to enforce anyway.
So I think the validation gas limit, at least that we have set, is like up to 1 million gas.
It's a big validation.
And the reason it's that is specifically because we had people trying out this passkey stuff, and they were using like 500,000 gas to validate the R1 curve, and people have since optimized that. But so we can probably bring that down to maybe, but when people start doing ZK stuff, they're probably going to need something higher. I mean, maybe we can bring it down on mainnets where people won't be spending that much gas on validation likely, but on L2s people might, right? Because it's cheap on L2s. So the issue is if the max is 1 million and a user only uses 100,000, and if that's for validation and the call portion is only using like 100,000, you're still only getting about 20% gas limit efficiency if you're using that 1 million gas as a bundler. And again, I think there's two problems here. There's one which is like a legitimate attack against the bundler, which will make the bundler lose like revert on chain and that sort of thing. The other one is just a bundler attempting to build, and this is kind of where I was coming from with the whole thing, was just the liveliness and throughput that we like of the entire mempool can kind of get attacked. Now again, like Jor said, you can mitigate this by submitting multiple transactions per block. But that does complicate things slightly. So I think the approach that we will take is likely the drop approach. Like if you say that your limit is 500,000 and you use 10, I don't know exactly what the threshold is going to be, but there's going to be some threshold where we'll probably just drop them and respond to the user saying, hey, you massively overestimated here.
Yeah, you can respond to the user if it came from a user directly via RPC. When it's the mempool, you don't have a way to communicate it to the user, but you can decide to silently drop it. Now, I wouldn't tag the sender as a spammer, because the sender peer, because then you find yourself out of the global mempool very soon. But but you can silently drop it. You don't have to bundle it. You can even safely propagate it in case another bundler does. Since you already simulated it, you might as well propagate it so that others will consider it. But you can say that your bundling strategy, each bundler can have its own bundling strategy. That's not something global to the network. So you can say that your bundling strategy is not to include these user operations, or maybe only include them when there is low volume anyway, like, maybe just keep them for later. So yeah,
we need to discourage this transaction. So maybe we should add, like, if we not only on a bundler strategy, but at the protocol level, say something like validation should use at least look, the validation is not should. Okay, validation shouldn't be as volatile as maybe execution of DeFi code. So it is expected that validation gas limit shouldn't be much more than like 30% than actual validation gas. So if we add it to the protocol, and all bundlers will reject user operation that initial validation takes much less than the validation gas limit, it will force wallets to perform better estimation on the validation gas limit. And again, I don't care if they do estimate user operation gas or they have a good constant in their code, because they know the contract code, they know how much gas it will take for validation in general. And it will fail if they put it too far.
Yeah, actually, this is, I mean, unlike execution, where you may have issues like pre-warming that changes the gas, with validation, you can accurately estimate, because it's the validation rules already prevent you from multiple validations from accessing the same things. So you will have minor differences because of accessing of contracts. Let's say you have multiple users of the same library, then the first one is going to make, so the estimation will have to assume a cold call to the library, whereas on-chain it may be a warm call. So there is a slight difference, but it's not a huge one. It's, I mean, you would have, in order for it to be a big difference, you would need to probably call hundreds of contracts, which is not reasonable.
Yes. Also, the storage warm cold issues is less relevant because
no, storage is not, because it's because you cannot access the same storage.
Yeah.
But you can access. I mean, the places that it could happen is calling into contracts, into library, doing delegate call, whatever. And there's also with paymasters, because paymasters, for example, can access, staked entities can access shared storage. So there is.
But I do believe that heavy validation will come from two aspects. One is deployment, and this is very specific to account. Like, you create your safe, you deploy a contract, you deploy helper contracts, and you tie them all together, modules, etc. And the other is heavy signature validation, which is CPU-based, which, again, doesn't change much between validation and execution.
Mm-hmm.
So I think limiting like 20%, 30% overhead for validation gas at validation time is a good, at the RPC level, and define it in the protocol.
But I think if in this case, I mean, since you're not going to penalize them, but actually to drop them, then maybe here it does make sense to also start at a certain constant and not at zero, so that if you have something that uses a very efficient, let's say you have a validation that only does EC recover on a constant, so it's a very cheap. The account validation is very cheap, and then it uses a paymaster. And now the paymaster accessing its own storage becomes, or its deposit becomes, a large part of the validation. And this, and now when it gets pre-warmed by another transaction that uses the same paymaster, it becomes significant enough to cause the operation to drop. So since it's not, you're not penalizing 10% of the unused gas, but actually preventing the operation, I would say that this shouldn't apply to very small operations, to operations with very small, very low verification gas. Dan, what do you think?
I think that seems reasonable.
This is just adequate. It's either 50K, if it is above 50K and taking, or 100K and taking more than 30% off the verification.
Yeah, and we do it as a validation rule and not in the entry point itself. That seems pretty reasonable to me as a way to prevent this. And one thing to note is I actually do expect most wallets will be using constants for validation gas limits, because there's no reason to
to
use that number when you've gotten the same number 1,000, 100,000 times across all the UOs you sent. Not a lot of teams are doing dynamic validation, so I do expect the constant to be the more common.
But I'm sure this is going to break. Sorry, go on, Ron.
By the way, either constant or another way, we add an explicit error for that. Like if we have an explicit error saying failed because of validation gas is XYZ, then submit the user operation, cache the result because it gave you the answer, what you should put in the future, and continue from there.
Yep, that makes sense. But I'm sure this is going to break quite a few SDKs out there right now once we start introducing this, because
it should break them if they overestimate. Like, this is a good breaking change.
But there are reasons why that's the buffer is added. Firstly, not necessarily to ensure the bundler is not grief. Secondly, it's used as a kind of a revenue generation model for SDKs to. I
just mean that there is a friction, there is a trade-off for every entity, like between the SDK ensuring something for themselves, either it's revenue or that the user operation is never going to revert. On the other hand, they are not incentivized to take care of the bundler's incentive here. So if they don't play fair, it's completely fine that they are getting taxed for it.
Fair enough.
Just call the proper estimate gas, put proper values over there, and it's not going to be an issue, I assume.
And if they use the gas estimation by the bundler, then the bundler estimates the verification gas anyway. You get you get multiple values returned. So one of them is the verification gas. So they don't do any extra work in order to estimate it.
The problem is that verification estimate user operation gas is not fully defined. The value is still not valid, and SDKs, and also we do some magic around it to support it. So that's one of the root cause of the problem. The other is that yet another RPC call just for that is annoying, and you want to skip it.
Yep. Okay. So
anyway, I think we are. So I think we agreed that. So we agreed that we are going with the unused gas change, but we are removing the constant and starting it and applying it to all user operations, right?
Yep.
And then and for verification, it's going to be an off-chain rule. Yeah. So should this rule be added to? Do you want to apply this like locally in your bundler, or do you think it should be at the network level? Dror, I think you suggested doing it at the network level, right?
Yes, we're adding it to the parameters. Yes.
Okay. The next one on the same topic, there was a vulnerability that Take raised. Any further comments on that? Are we just going to update the reference implementation to add invalid opcodes for the tracer, or is there a suggestion on how you want to address that?
So first, I'm fine with the blocking, like with banning invalid and unassigned opcodes, because they have no valid. There's no valid reason to use them. But it didn't. But there wasn't an attack. There wasn't a vulnerability. I think he misunderstood what constitutes an attack. It doesn't actually allow you to invalidate something that passed. That successfully passed a simulation. It just causes the simulation to revert in a different place, but it's still reverting simulation. You're still not going to accept it to the mempool. So as far as I understand, there is no vulnerability.
Yes, the invalid opcode itself, as you have said, doesn't cause anything. Blocking other opcodes, I think it is important when we do a cross-chain. because if one chain defines an opcode to do something, and you have a wallet that allows it, so in many chains it doesn't affect, and in that specific chain suddenly there is an attack. So just like we block all precompiles except the first known,
yeah,
just the same, we block all opcodes, and I need to think whether we explicitly specify what are the blocked opcodes or reverse and eventually define what are the whitelisted allowed opcodes. I need to see which of these.
I think it makes sense. It's
right, because they're spread all over in the matrix of user operations of opcodes. Sorry.
So it's not just for different chains, but also on the same chain. Let's say there's going to be a fork. There's going to be a fork, and a new opcode is being added, like a T-store T-store that is going to be added in Cancun. So when a new opcode is added, and you don't block it, maybe it's an opcode that can enable reverting on chain somehow. You can detect it and revert, and if the opcode becomes available, becomes usable, then you decide to revert. So it means that just around the time of you can cause a lot of bundles to revert at the time of the fork. So bundlers will momentarily lose money by actually having on-chain reverts right after the fork. So they probably shouldn't. So before the time of the fork, they shouldn't accept this opcode, but it means that they need to become aware of forks and add, like let's say in the case of transient storage, the bundlers need to be aware that at a certain block number at Cancun, transient storage is added, and then the rules change and this opcode becomes valid.
Right.
This will be a new mempool. The definition is still we allow access to storage, memory, stack, and call between accounts. We don't allow anything else. Now we need to explicitly specify what is else means. So the code mapping.
Yeah.
Okay.
I have two quick things. I know we only have a couple of minutes left. That I wanted to bring up on the validation rules PR. Do we have time for that?
Sure.
Yes.
Okay. So real quick, a couple things. I think a little bit more clarity in those rules around two things. Really, how each rule can impact reputation. So there's some places in the PR there's some like imprecise language where we say like we throttle down, but we don't say like what throttle down means. If that just means just drop the UO and then let the reputation rule, like the obscene minus.
We need to look into it. Basically, we have the idea is that to minimize the state, we have obscene and ops included, and throttling down usually means raising obscene, so you become throttled for a period of time.
Yeah, so there is a definition.
So we need to explicitly say what we mean by throttling down. Usually that means I need to look carefully into the doc and make sure and add a definition what throttling down means and reference that. You're right.
Yep. So that's one.
I'm sorry. Go on.
No. Go ahead. I've got a couple more. So
okay. So yeah. So I don't think we should add a different kind of throttling. We already have throttling in the system. We already have a throttling in the system, which happens when the ops scene when ops scene becomes too high compared to the ops included. So in order to trigger throttling, we can manually change opsin, and then it triggers the same throttling. But the definition of what happens during throttling, this is well defined. It's you drop all the existing existing operations. You don't allow more than a number of ops in the mempool. So it is defined.
I think that explicit, like adding to ops in, like how the number to add, how like is,
yes, exactly. We need a definition of that. We can use the term throttle down, but right now it is implicitly defined. As I said, add this. We need to define what number to add.
Yeah.
And think what happens if the ops included at the moment is very high, because then what you need to add is okay. We need to look at the document and define it. I wrote it down that it is unclear what it means. We need to specify.
Just another place that's slightly unclear, and maybe the answer is it just applies to all, but it might be worth defining how each rule impacts, and maybe defining or using this as a suggestion or something like that, how each rule impacts peer scoring in the P2P mempool. Like if you get a particular rule that occurs, like if that rule should impact a peer score. There's a couple of rules, like I think storage 40 and 41 like are related to like the state of the mempool when you receive something, and it's possible that the peer hasn't gotten that. So that was one.
So you're completely right. There are rules that are really local to the bundler. For example, every rule that depends on reputation cannot be applied for peer scoring, because the other bundlers may not have the same reputation as your own. So you can't really punish them for sending you a user operation that is for an entity that is throttled down by you. It may not be throttled down by another bundler, right? So yes, there are rules that are more objective in terms of the bundlers, and some rules are really subjective to the bundler and cannot be used for peer scoring. So
it might help to define that, just to give clarification on which rules.
We need.
We intend to do it.
It should be two things. The two things you can do with the rules in terms of mempool. Some rules you can are soft for your bundler, and you drop user operation that arrives which break them, and other that caused you extra work, like validation that should have been skipped. This is an act of a spammer. We need to clearly define which one of which. The rule of thumb, again, it is not written. We need to follow and find some language to write it down. If it causes you an unnecessary hard work, it is a spammer. If it's just a nuisance, like you should drop it directly because the structure is broken, this is not spamming unless you have on the P2P protocol level some mechanism to find someone that sends pure garbage over the P2P, which is the same. Someone put validation gas limit 0. Okay, drop it because you don't have to do anything. It's impossible. So this is not considered. It's just a syntax.
Yeah, makes a lot of sense. And then the last one, and Partha, this is something that I would love to test as soon as we get our implementation ready, is I'm not sure, and I brought this up a few months ago, and I would love to know if anyone's tested this. I'm not sure if the way that we've defined the alternative mempools and the gossip protocol actually prevents a user from receiving, or a member of the P2P mempool receiving the same user operation on every mempool that they're part of. Because I don't think there's cross-topic deduplication in libp2p by message ID. So that is something that like we'll have to at least, there's language in the, I think it's a alt 30, which says we should try to prevent sending the same UO to the same peer twice.
Right.
I don't think libp2p has that sort of
No, I did test
ability.
this out, but then when you brought this up, I did run a POC, not necessarily on the bundler, but as a separate one. I believe libp2p internally has this ability to prevent a double sending of messages across multiple channels. So I tried to test this, and I received just once. The second one didn't, but yeah, I'm happy to test out this when we do the P2P.
Yep, I'll be testing that out soon, and I'll let you guys know what I see on the Rust side. It might just be it might even just be on the library that you're using. I couldn't find any language in the libp2p spec that said they would do that, but maybe
no, not necessarily on the spec, but there was one example. I'll share the links that I came across when it's there.
Awesome. All right, thanks everybody.
Okay, just one question about the tracing. Right now, the tracing, I believe everybody is still doing tracing using JavaScript on Geth, right? Because did anyone did a comparison test of Geth or Rust or whatever, the performance of a JavaScript tracing versus native code tracing? Anyone did some work on that? At least of the standard tracers like access list tracers or call. Because this is something. Because one thing that I started, and again, put it aside because of too many things, but it is important, is to rewrite the structure of the tracer. Make it more like the call tracer. There is a call tracer that creates a call stack. I thought of adding the necessary information we need to that, and based on that tracer, again, start from the legacy JavaScript tracer and add the opcode and such into it, and then you have the equivalent native code tracer because this is a standard one, and add it to that. But it will make some of the things that our current tracer can't do. It will make possible. Like the tracer as it is today doesn't allow you, for example, create a wrapper transaction to wrap multiple simulate into a single debug trace call and then split it between. Because you do need to handle a deeper level. And the tracer as it is today is hard-coded on calling from the depth 1 to depth 2. So we do want to do it, and one of the reasons is supporting native. But if no one did it yet, okay.
I mean, there's again the challenge of the client supporting it, right? I think at the moment, Nethermind does not even support custom tracing, as far as I know. So I'm not sure how far writing a native tracer might be compatible with the available clients.
Yeah, you'd have to run your own nodes. The node teams aren't gonna merge this tracer in, at least for 457. Maybe they definitely will for native, but for 457 they're not going to merge this in. So I don't expect.
Why do you think JavaScript they will use JavaScript tracer and will not use a native code tracer?
Oh no. I'm just saying that they're not gonna merge in a 437 specific tracer without a lot of reasoning too, like native account abstraction. Especially when they can just be like, oh, just fork the code base and put your tracer in and run your own nodes.
Yes, you will run your own node and you run a module. What I'm saying is that, okay, you are running your own nodes in order to do the tracing, but right now the tracer is an external module written in a very bad language. I right now use an Apple Silicon, and tracing takes like over a second when you run an x86 code. It is terrible.
Yep.
Compared to, again, tens of milliseconds of a transaction.
Yep.
So, of course, this is not a real case. You should use native code. Even for
we have a to-do to look at this and likely adding, hopefully, to our node fleet these sorts of tracers. It's a little bit of work on our end to maintain it, but we'll see. And then maybe we can even push the client teams to put a 437 specific tracer in there, but we'll see. All right, I gotta drop. Nice talking to you guys.
Okay, what nodes? Okay.
Cheers. Okay then. Fine.
Bye.
Thank you.
Okay.
Have a nice day, everyone. Cheers. Bye.
Bye.
Yeah, bye.
All right, take care.